let's look at another example illustrating two-dimensional motion or motion in two dimensions. In particular, where in one of the dimensions we have the gravitational pull or the force due to gravity. Now, in this case, we are going to have an airplane moving at a constant velocity along the horizontal direction, and the package initially inside the plane moving at that same horizontal velocity. And then we let go of the packet. Okay, I'll press a button and the packet is going to be let go of. Now, once we let go of the packet, the only force that's going to be acting on the packet is going to be the gravitational force. That's straight along the vertical, so Fg, Earth on packet. Now, because of that force, the only acceleration that the packet is going to have is going to be along the vertical direction. Now, the initial vertical velocity for the packet is 0, since initially it was moving only along the horizontal. The initial horizontal velocity of the packet should be the same as the initial horizontal velocity of the airplane, since it was moving along with the airplane. And that's what we should be able to observe. Okay, here we go. This is my simulation. This is the airplane. See the airplane here. Once I start playing, the airplane is going to be moving. I can control the altitude of the airplane and its velocity here. I'm not going to do that. I'm going to take the default values. I'm going to tell it to show us the velocity. It allows us to have air friction, but I'm not going to play with it yet. I'll try it in a little bit. And then it allows us as well to see the motion relative to people in the airplane. But I'm not going to do that for this particular topic. Now, this button here that you see there is going to allow me, okay, I don't know what happened here. This button here with the red X is the one that I can use to drop the package. Okay, let's try. The button with the red X is the button I can use to drop the box or the package. The button with the red X is the button I need to press to release the package. Okay, let's go try it. Okay, here is the airplane moving at a constant velocity. And then I release the package. And notice the package. Okay, I'm going to do the button here with the red X is the button I need to press to release the package. Okay, let's go ahead and do it. Okay, it is moving, the airplane is moving. I release the package. Notice the horizontal position of the package is in line with the horizontal position of the airplane, but the airplane continues at a in the horizontal direction, while the package moves in both directions, vertically and horizontally. Okay, let's repeat this. Okay, show the velocity again. Okay. Horizontal velocity of the package is the same as that of the airplane. Vertical motion is free fall for the package. Now, I'm going to add a resistance. When I add a resistance, the package is going to experience two forces along the vertical, which are the gravitational force downwards and a resistance upwards, and one force along the horizontal, which is a resistance. What I'm trying to say, a resistance is going to affect the package in both directions, not just the vertical, not just the horizontal. It will affect it both ways. Because a resistance is going to affect it in the direction of the motion opposite to the motion. So the a resistance, let me go here, at this point is going to point this way. Here, it's going to point this way. And you notice that in both cases, this has both a horizontal and a vertical contribution. This is the horizontal contribution, and this is the vertical contribution. The vertical contribution opposes the gravitational force. The horizontal contribution is just opposite to the direction of the horizontal motion. Okay, let's go to that. Okay, now we are going to have reset, show velocity, air friction, okay, and we play. Okay, we release the package, and notice now that the package is going to drag behind the airplane. The package is not going to be moving horizontally at the same velocity as the airplane. In this case, the package is going to have an acceleration along the horizontal as well as an acceleration along the vertical, while the airplane is moving at a constant velocity, no acceleration in either direction. Let's look at another example. The other example is a drop from a bridge. It should be exactly the same. Okay, we'll see it using a simulation in this case. Another simulation. Okay. So we start. Okay, you notice here the red and the blue balls. The red ball is going to continue. I can do slow motion here. The red ball is going to continue along with the train, and you notice the blue ball. This simulation allows us to see the velocity components. You notice the locomotive or the red ball has an arrow along the horizontal, a constant arrow along the horizontal. For the blue ball, the overall velocity is shown here. That's the overall velocity. However, that velocity has both a horizontal and a vertical component. And as you notice, the horizontal component never changes, while the vertical component is increasing. And that's what we see. Okay, I'll reset it.